Mga greetings, I'm BATIANCILA. In this video, I will be explaining the class diagram of our quick mark point of sale system. This diagram shows the structure of our program and how each class relates to one another. Let's start with the product class at the center bottom of the diagram. Product is an abstract class, meaning it cannot be created directly. It serves as a blueprint for all product types in our system. It contains common attributes such as product ID, name, price, category, and stock, as well as methods like reduce stock and restore stock. Now, branching out from product, we have three subclasses: beverage, snack, and household item. Each of these inherits all the attributes and methods of product, and each adds their own unique attribute. Beverage has volume, snack has weight, and household item has usage. The hollow triangle arrow pointing to product represents inheritance. Moving up, we have cart item. Cart item represents a single product entry inside the cart. It holds a reference to a product and a quantity. The association between cart item and product has a multiplicity of 1 to 1. Meaning one cart item references exactly one product. Next is the cart class, which is a singleton, meaning only one instance of cart exists throughout the entire program. Cart has two important relationships. First, cart has a composition relationship with cart item, with a multiplicity of 1 to 1 or more. This means one cart contains one or many cart items, and if the cart is destroyed, the cart items are destroyed along with it. Second, cart has an aggregation relationship with cart observer, with a multiplicity of 1 to 0 or more. This means one cart can have 0 or many observers registered to it. Speaking of cart observer, it is an interface that declares one method, which is onCart updated. POSFRAME implements this interface, shown by the dashed line with a hollow triangle pointing toward cart observer. This means POSFRAME is required to provide its own implementation on cart updated. This is observer pattern in action. Whenever the cart changes, it automatically notifies POSFRAME to update the display. The multiplicity between cart and POSFRAME is 0, 0, 1 to 1. One POSFRAME uses one cart. Lastly, we have product factory. This class is responsible for creating product objects. It uses the factory pattern to centralize object creation. The association between product factory and product has a multiplicity of 1 to 0 or more, meaning one product factory can create 0 or many products. To summarize, our class diagram demonstrates 4 object-oriented principles: abstraction through the product abstract class, encapsulation through private attributes and public methods, inheritance through beverage, snack, and household item, extending product, and polymorphism through the overriding of get category label and get description. It also applies 3 design patterns: singleton for cart, or observer for cart and POSFRAME, and factory for product factory.
Greetings everyone, I'm Leilin ASUNCION and I'm going to discuss our program called Quick Mart, which is a simple shopping cart system designed for a convenience store setup. So basically, this system allows users to add products, manage their cart, and generate a receipt, just like what we experience in a real stores. Product examples. Beverage class. Let me start with one of our product classes, which is the beverage. In our code, we created a class have the class beverage extends product. This means that beverage is a child class of product. So instead of rewriting everything, we reuse the attributes like product ID, name, price, and stock. We also added a unique property, private string volume, because beverages usually have sizes like 500 ml or 1 liter. Then we use polymorphism by overriding a method, get description. So instead of a generic description, it returns something like Coke 500 ml refreshing beverage. So each product type can have its own way of describing itself. Next is the card class, which is one of the most important parts of our system. We use something called the singleton pattern, meaning only one card instance exists in the whole system. In the code, private static card instance, and we access it using card.getInstance. This ensures that all actions like adding or removing items happen in one shared cart. Next is adding items to cart. When adding items, we check first if the quality is valid. If there is enough stock, then we either update the quantity if the product already exists, or add a new item to the cart. We also reduce the stock using product.reduceStock quantity, so it stimulates real inventory behavior. Next, observer feature. We also implemented the observer pattern. We created an interface, cart observer, with the method onCartUpdate. So every time the cart changes, all observers are notified. This is useful for things like updating the UI or showing the real-time totals. Cart computation. Subtotal, tax, totals. The system also calculates the subtotal, tax, 12% VAT, and grand total. For example, get subtotal and adds all items subtotals. Get tax amount, subtotal times 0.12. Get grand total, subtotal plus tax. So it's very similar to how real receipts are computed. Receipt generation. One of the best features is the receipt generator we use. We use generate receipt string transaction ID. It prints transaction ID, date and time, list of items, and subtotal, tax, and total. And it formats it like an actual store receipt, including thank you for shopping at Quickmart. Other product example, household item. We also created another class, household item extends product. This one includes a field like usage, example, cleaning or hygiene. And again, we override get description, so it returns something like detergent, cleaning product. This shows inheritance and polymorphism working together. Cart item class. Each item in the cart is represented by cart item. It contains product and quantity, and it calculates its own subtotal. Price times quantity.
Dangal greetings everyone, I'm DEVERA and I'll be explaining four classes, which is the main, product factory, and the snack class. So let me start with the main program. This is the entry point of our entire application. It only has one job, and that is to launch the program. Inside the main method, we first set the look and feel to say to the system default, so the app looks clean and native on whatever computer it runs on. Then we use a swing utilities invoke later to launch our POSFRAME class, which is our main window. The reason we do it is this way is because Swing has something called the event dispatch thread, and all GUI components need to be created on the thread to avoid bugs and crashes. So this one line makes sure everything starts up safely. Next is the product class. In this one, it is very important because it demonstrates two of OOP principles at once, abstraction and encapsulation. First, notice that it is declared as abstract. That means you cannot create a product object directly. You cannot say new product. Instead, it serves as a blueprint that other classes must follow. For encapsulation, all the fields, product ID, name, price, category, and stock are declared as private. Nobody outside this class can touch them directly. Instead, we provide getters like getName and getPrice and setters like setPrice and setStock to control access properly. We also have two methods for inventory tracking: reduce stock, which checks if there's enough stock before deducting, and restore stock, which adds the quantity back if an item is removed from the cart. Now the most important part, the two abstract methods, get category label and get description. Because they're abstract, every subclass that extends product is forced to provide their own version of these methods. This is what sets up our polymorphism, which my groupmates will explain more when they discuss other subclasses. Now let me talk about the product factory class. This is where our factory design pattern is implemented. The problem it solves is this. In our system, we have multiple type products, beverage, snacks, and household items. Instead of manually writing new beverage or new snack every time we need a product, we centralize all of the creation logic here in one place. The main method is create product, which takes a type, string, and the product details as parameters. Inside, it uses a switch statement. If the type is beverage, it creates beverage. If it's snack, it creates snacks, and so on. This makes our program much cleaner, and easier to maintain. We also have create default catalog, which calls create product 24 times to build our full Quick Mart product list: 8 beverages, 8 snacks, and 8 household items, all in one place. The beauty of factory pattern is scalability. If in the future we want to add new category like frozen foods, we just add one new case here in our factory, and the rest of the system doesn't need to change at all. And finally, the snack class. This one is straightforward, but it clearly demonstrates that inheritance and polymorphism. Snack extends product, meaning it inherits everything from the abstract product class. All the fields like name, price, stocks are already there from the parent. Snack just adds one extra field specific to snacks, which is weight, like 85 grams or 100 grams. The constructor calls super first, which passes the common details up to the product's constructor. Then it sets its own weight field. Now for polymorphism, snack overrides both abstract method from product. The get category label method returns the string snacks, and the get description method returns a custom description that includes the product name and its weight. This is polymorphism in action. The same method name, get description, behaves differently depending on whether you're calling it a beverage, snack, or household item. And that's all for my part. Thank you for listening.
Greetings everyone. My name is Shane Marian DADULLA and today I will be explaining our point of sale system implemented in Java using Swing. This class is called POSFRAME and it serves as the main graphical user interface of the application. Let's start with the structure of the program. At the top, we import necessary libraries such as Swing for GUI components, AWT for layouts and events, and utility classes like list and UUID. Next, we define the class. Public class POSFRAME extends JFrame implements cart observer. This means our class is a JFrame, or a window, and it also implements the cart observer interface. This allows the system to automatically update the interface whether the cart changes, which is an example of the observer design pattern. Inside the class, we declare several variables. First are constants for the colors and fonts. These are used to maintain a consistent design across the application, such as background colors, button styles, and the text formatting. For example, private static final color BG app is equal to new color 181235. These colors are used to create a consistent theme of the application. Instead of hard coding colors in different parts of the program, we define them once and reuse them. I won't go through each one individually since it would go too long. Then we declare UI components like combo box for the category filtering, JList for displaying products, JTable for cart and inventory, JLabel for totals and statuses messages, JSpinner for selecting quantity. We also declare a list called catalog which contains all products, a cart object which stores selected items. Now let's move on to the main method. The main method uses the event queue invoke later, which ensures that the GUI runs on the correct thread. Inside it, we create an instance of POSFrame and displays it. Next is the constructor, public POSFrame. This constructor initializes the entire application. Example, cart is equal to cart.getInstance. This line shows that we are using the singleton pattern to ensure only one cart exists. First, we use UI manager put to customize the appearance of all components globally. This includes settings, colors of the panels, buttons, tables, and the text fields to create consistent dark theme. Then we initialize the cart using cart.getInstance. We also register the current class as an observer using cart.addObserver. This allows automatic updates in the UI. Next, we load the product catalog using catalog is equal to product factory that create default catalog. This use the factory pattern. We assign the catalog to display products, which is used to display item in the UI. Then we configure the frame, set default close operation, jframe.exit on close, content pane is equal to new jpanel, set content pane, and finally build UI, which build the whole interface. And now let's look at the UI structures. The build UI method sets the user title, size, and layout. It adds three main sections, the header, body, and the status bar. The header contains the system name, cashier, info, date, and time. The body is divided into two parts. The left side shows products and the right side shows cart, summary, and the inventory. In the product panel, we use a JCombo box to filter categories, a JList to display products, a spinner to select quantity, and a button to add item and to the cart. Each product is displayed using a custom renderer called Product Cell Renderer. Now for the second constructor inside the class, Product Cell Renderer, set layout new border layout 10, 0. This defines how much product item is arranged visually. Another example, icon LBL that set font, new font, Sergio UI emoji, font.plain 22. This sets the style of the icon displayed. This constructor customized how each product appears in the list by organizing labels, icons, and prices. In the cart panel, we use JTable to display selected items. Each row shows product name, category, price, quantity, and the subtotal. In the summary panel, we calculate subtotal, apply VAT, and displays the total amount. The inventory panel shows all products along with their stock status: in stock, low stock, out of stock. Now let's explain the main functionalities. The filters products method filters products based on the selected category. The add to cart method checks if the product is selected, validates stock availability, adds the item to the cart. The remove selected item method removes a selected item from the cart. The clear cart method clears all the item after confirmations. The checkout method handles the payment. It asks the user to input cash, validate if the amount is enough, calculate the change, generate a receipt, then clears the cart. Next is the one cart updated method. This method updates the cart table, item count, subtotal, tax and total, product list and the inventory. We also have helper methods like style table, BTN, warn, set status. To summarize, this program demonstrates GUI designed using Swing, object-oriented programming using design patterns like singleton, observer, and factory, real-time UI updates, and that concludes my explanation for this class. Now let's move on to the output of our program. This is the point of sale or the POS system built using Java Swing. The main window is divided into several sections: the header, product panel, shopping cart, order summary, inventory tracker, and action buttons. Each section works together to simulate a real cashier system. At the top of the system, we have the header. This shows the system name QuickMart, the role of the user, the cashier admin, the current date, and the current time. The purpose of this section gives identification and real-time information about the session. For example, when a cashier is using the system at this time, the header automatically shows the correct time and date so they know the transaction is properly recorded. On the left side of the panel, it contains a category filter dropdown, a scrollable list of the products, a quantity selector or the spinner, and an add to cart button. Inside the category filter, you can filter products like beverages, snacks, household items, or the all categories. For example, if you select beverages, only Coca-Cola, Sprite, and similar items will appear. Each product shows the name, stock availability, price, and an icon based on the category. For example, if Coca-Cola is selected, it shows Coca-Cola, the price 25 pesos, and the stock is 50. In this field, a quantity selector of a spinner, you can choose how many items to buy, like 1, 2, or 5, then click Add to Cart. For example, if you select the Sprite, quantity is 3, then click Add to Cart. It will add 3 Sprite bottles into the cart. Now in the center of the panel, this is the main transaction table. It shows the product name, category, unit price, quantity, subtotal per item. For example, if you buy Coca-Cola is the quantity times 2, it's 50 pesos. Sprite 1 is equal to 25. The table will show each item and calculate subtotal automatically. It also shows the number of items in the cart at the top. And now in the right panel, this shows the total calculation of the cart. It includes subtotal, VAT 12%, total amount due. For example, if subtotal is 100, VAT 12% is equal to 12, subtotal due is 112. This helps the cashier knows exactly how much to charge to the customer. Next, in the center bottom section of the panel, this shows all products in the system including stocks levels. It displays product ID, name, category, price, stock quantity, status if it is in stock, low stock, or out of stock. For example, Coca-Cola, 50 stock in stock. Milo, 5 stock, low stock, sold out item, out of stock. This helps monitors product availability in real time. This button over here, the remove item, removes a selected item from the cart. For example, if you mistakenly added 3 Sprite, you can select it and remove it. Next button, the clear cart, removes all the item in the cart. For example, if the customer cancels the purchase, the cashier clicks clear cart to reset everything. And lastly, the bottom checkout. This is the final payment process. It shows total amount, asks for cash input, calculates change, generates receipts, and then clears the cart for the payment. For example, if the total is 200, customer gives 1,000, the system calculates the change and it receives it, and the receipt is generated automatically. After clicking checkout, the program prompts the cashier to enter a cash amount to given by the customer. The cashier inputs the amount of this. After receiving the payment, the system automatically computes the change by subtracting the total amount due to the cash given. In the receipt, you can see the name of the store, Quick Mart, the transaction ID, the date and time, and you can also see the items you bought or the customer bought, the quantity of each item, and the subtotal of all items. The tax is also shown and automatically calculated. Finally, a short thank you message is displayed. You can also see the cash given by the customer and the change returned to the customer. And that's all. Thank you for listening.
I just had to let you know you're